Welcome to this explainer. If you've ever spent hours, maybe even days, perfecting a trading algorithm, you already know there is a massive difference between generating a brilliant signal in a backtest and actually getting that trade executed live on the market. Today, we're bridging that exact gap. We're going to completely decode the mechanics of how your code actually interacts with a live market.
We're tackling a really foundational question for any algorithmic trader today. How exactly does a trading robot communicate its intent to the broker's server? It's not magic, right? It's a highly structured, super precise data exchange. And honestly, understanding this invisible network handshake, that is exactly what separates novice script kiddies from professional quantitative developers.
All right, here's what we're looking at today. First, we'll cover MQL5 programs. Second, execution modes. Third, the trade request. And finally, trade transactions.
Okay, let's dive right into part 1, MQL5 programs, the real decision makers here.
Now, not all MQL5 programs actually have the authorization to pull the trigger. Expert advisors, or EAs, those are your heavyweights. They can fully automate your trading processes because they react to live market events. Scripts, on the other hand, are more like single-use tools. They execute a programmed action from start to finish, and then they just stop. Services, well, they run quietly in the background, completely unbound to any chart. But take a close look at custom indicators. While they are absolute mathematical powerhouses for analyzing data, they explicitly cannot trade automatically. So when it really comes down to initiating that network communication to place a trade, EAs and scripts are your actual trigger pullers.
Moving right along to Section 2, Execution Modes, basically the rules of engagement.
So there's a pretty massive contrast between instant execution and market execution. With instant execution, your platform automatically bakes the current price right into your order. The broker then either accepts it or, if the market moved, they send back a requote with the new prices. You're getting a guarantee on the price, sure, but you risk missing the entry altogether. Market execution is the exact opposite. Your order is executed at the best available market price, no matter what, zero requotes. You are guaranteed the entry, but you're accepting whatever the prevailing price happens to be at that exact millisecond.
And just to complete the picture here, we also have request execution. Think of this one as kind of like a two-step handshake. Your program specifically asks the broker for prices first, and once the broker replies with those available prices, your algorithm can then decide to confirm or reject the execution based entirely on that quote.
All right, Section 3, the trade request. Let's look at the actual plumbing of an order.
The really crucial thing to grasp here is that a trade command isn't just, a simple line of text. It's a meticulously packed data envelope known as the MQL trade request structure. Every single time you want to interact with the market, you have to manually pack this structure with exact details. You declare the action, like trade action deal, the symbol, the volume, the order type, and the price. If you leave out even one mandatory field or format it incorrectly, the server's gateway is going to reject your order outright. No exceptions.
And this brilliantly illustrates the strict three-step code lifecycle you absolutely have to follow to place an order. Step 1. You zero out and initialize your MQL trade request and MQL trade result structures to completely avoid any memory errors. Step 2. You meticulously fill in all those mandatory parameters we just talked about. And Step 3. You call the order send function to actually transmit that data payload across the network straight to the server.
But hold on, I need to pause here for a second and highlight a really critical distinction straight from the MQL5 reference. It states that if the order send function call completes successfully, it just means the trading server has put the order into the queue for execution. Please remember this. A successful order send simply means the pipe is laid and your data has safely arrived in the server's queue. It absolutely does not mean your deal is closed or your position is actively open in the market yet.
Which brings us to Section 4, Trade Transactions. This is all about the server's reply. Now, you really have to embrace a vital technical reality when writing these network functions. Priority is not guaranteed at all. One single trade request from your robot can generate a flurry of different server actions. The server has to add the order, execute the deal, and then alter your position. These confirmations are sent back to your terminal as individual transactions. And here's the kicker, they might arrive entirely out of sequence. You just cannot build a robust algorithm assuming these events will show up in perfect chronological order.
So, how do we actually catch all these scattered replies? Well, enter the onTrade transaction event handler. Honestly, think of this function as your trading robot's passive inbox. It just sits there, continuously listening for any updates the broker sends over regarding the state of your account.
Inside that inbox, you're going to get a few different types of notifications. Trade, transaction, order, add tells you the server has officially registered your pending order. Trade, transaction, deal, add. That's the golden ticket. It means your deal executed and was successfully added to your history. Trade transaction position indicates your volume or stop levels just shifted, and trade transaction request means the server is completely done processing your initial request. Your script basically uses these individual puzzle pieces to reconstruct the real-time narrative of the trade's entire lifecycle.
But I gotta give you a really clear warning for your code here. The MQL trade transaction structure is populated completely differently depending on which transaction type just arrived. You absolutely must check the transaction type first before even trying to read the data. If you try to extract a deal price from an order modification transaction, your algorithm is going to read garbage memory. And trust me, your robot will make catastrophic trading decisions based on that. Verify the type, then read the data.
Now, this whole asynchronous setup poses a pretty common developer problem, right? Let's say you're firing off multiple trades across different symbols. How do you actually link the server's incoming transaction back to your script's original order send request? Like, how do you know which reply belongs to which specific order?
The elegant solution to this is the request ID field. Think of it kind of like a FedEx tracking number. When your terminal initially dispatches the order send request, it automatically stamps it with a unique request ID. Later on, when the server sends an on-trade transaction event back to your inbox, it tucks that exact same request ID right inside the MQL trade result parameter. This tracking number is your bridge. It seamlessly, perfectly associates your outbound action with the inbound server confirmation.
Mastering these structures, the meticulous packing of requests, handling the different execution modes, and correctly tracking asynchronous replies, that is exactly what elevates your code from a basic script to a robust, institutional-grade system. So are you ready to stop guessing if your trades actually went through and start executing with absolute precision? Thanks for watching this explainer, and happy coding!